Okay, this is a video to correct question 6 from the series of revision. So if you didn't do that question, please stop the video and go ahead and try it. After that, return to the video and check your work. Right, let's read together. So Paul buys a number of large sack of fertilizers, costing X dollars each. So this is a sack of fertilizer, and the price for that is X dollars. All right, so this is only one sack, and the price of one sack is X dollars. He bought the total of his sacks, $27. So he spent $27 for all the sacks, not the price of one sack, but all the sacks. Now write down in terms of X, an expression of number of large sacks with which Paul buys. So I know that the total price will be equal to the price of one sack, large sack, let's say, large sack, times the number of large sacks, right? So this is normally how we get that. So the total price is 27, right? The price of one sack is X, and the number of large sacks, this is what we are looking for. So number of large sacks, right? So the number of large sacks multiplied by X is equal to 27. It's easy for me to get the number of large sacks in terms of X. I just need to divide both sides by X, knowing that X is not 0 for sure. You can't buy a sack of fertilizer for $0. So I know that the number of large sacks is equal to 27 divided by X. When you divide both sides by X, you get rid of this X and then switch sides, right? So this is a final answer, and I got the number of large sacks in terms of X. This is the expression. Now, this is what Paul bought. So the number of large sacks, or what Paul bought. So Paul bought 27 over X large sacks, right? Okay, now let's talk about the second. So this is for B. Rula spends $25, so he bought 25 with $25. Let's read again. So Rula buys a number of small sacks of fertilizer, so he is buying a different category. Each small sack costs $2 less than a large sack. Right, so if I know that the price of large sack is X, right? What is the price of a small sack? So the price of a small sack, small sack. Here they said that the price of small sack costs $2 less than a large sack. So if the price of a large sack is X, the price of small sack is X minus 2, because it's less than that price with the $2, right? Now, Rula spends $25. Write down in terms of X an expression of the number of small sacks Rula buys. So I know that the number of small sacks, the same strategy as we did, times the price of a small sack. This will give you total price, right? So the number of small sacks, so this is what we are looking for, number of small sacks, times the price of a small sack. The price of small sack, we already talked about that, so it's times x minus 2 is equal to the total price, which is equal to 25. Now, it's easy for me to get the number of small sacks. I just need to divide both sides by 25. So number of small sacks is equal to 25 divided by x minus 2. So this is what we are looking for. I got the formula for the number of small sacks. All right. Now, let's talk about this. Ruler buys 4 more sacks than Paul. So I know that the number of sacks that ruler buys is equal to, so it's more than the number of that Paul bought by 4, right? So it's 4 plus the number of sacks that Paul bought. Right. Well, I have an expression for that. So the question was, write down an equation in terms of x and show that it simplifies to 2x squared minus 3x minus 27. So let's focus on this one and how to write it. So I know that the number of sacks that Paul buys is 4 more sacks than Paul. So I have the expression for the number of small sacks, which is that ruler bought. So this is for ruler, right? So I have 25 divided by x minus 2, right, is equal to 27. It's equal to 4 plus 27 over x, because this is the number of sacks that Paul bought, right? So this is the one that I'm looking for. Right, I have an equation like that. I just need to try to transform this. How can I go from here to something that is close to 2x squared minus 3x minus 27 is equal to 0? So I need to do everything to get to a quadratic equation here. Well, we saw that this technique when we were solving an equation like that, right? Because second question will be to solve the quadratic equation. So instead of telling you that you need to solve this directly, they made it into 2 questions. Right, let's try to solve this one. So I have x minus 2 here and x here. So what should I do to get rid of this x minus 2 and this x at the same time? Well, we saw this technique before. I just need to multiply both sides by x times x minus 2. So you just see whatever in the denominator and you multiply both of them, and then you will get rid of x in the denominator. You will have something without fractions, without troubles, and you just need to simplify that expression and expand the brackets and collect the like terms and all of that. Well, let's try to write it in the same page. So I will start by writing 25 over x minus 2 plus 4. No, it's 25 over x minus 2, yeah, is equal to 4 plus 27 over x. So this is what I will do. I will multiply both sides. So this one I will multiply it by x times x minus 2, and this one I will multiply it by x times x minus 2. Be careful when doing the multiplication in this side that you are multiplying this full as well, right? Don't forget about this one. Well, either from the start you write it as one single fraction, or you don't really care about that. You just need to write it like that, and after that make sure that you will multiply this 4 by x times x minus 2. Well, let's do that. Well, when doing the multiplication on this side, I will get rid of this x minus 2 because I have total multiplication of this bracket. So on this side, I will have 25x. And on this side, I will have 4 times x minus 2, since I will be expanding this bracket. So it will be 4 times this bracket plus 27 over x times x minus 2, I will kill these two x's. So, well, I will write it maybe, and after that discuss the simplification. So I can see that these two x's will be killed. So as a result, I will have 4x, let me write it in a better way, 4x minus 2 plus 27 over x times x minus 2. Now I just need to expand the brackets and collect the like term. So I have 25x is equal to 4x times x, it will be 4x squared, minus 4x times 2, which is equal to 8x, plus 27x minus 54. Now I need to collect the like terms here, so it's up to you how to do that. Either I will take this 25 to this side and 25x to this side, and I will say 0 is equal to all of that, and then switch the sides. So I can write like that. 0 is equal to 4x squared minus 8x plus 27x minus 54 minus 25x. And then I can simplify this side and I can put it on the other side. So I have 4x squared and 27x minus 25x is equal to negative 2, negative 2, wait, did I forget something about this? I have, yeah, 25. Yeah, 25 and 2 plus negative 8, it's negative 6x, right? And at the end, I'm left with negative 54 is equal to 0. Well, this is not exactly what they were asking me to get. The question was I need to arrive to 2x squared minus 3x minus 27 is equal to 0. Well, I got a different thing. But if you focus a little bit, you see that if I will divide all of this side or both sides by 2, I will get exactly what I'm looking for. Because 4 is a multiple of 2, 6 is a multiple of 2, and even 54 is a multiple of 2. So if I will divide this by 2, I will get exactly 2x squared minus a 3x minus 27 is equal to 0. So I've proved that this problem simplifies to solving this equation, this quadratic equation. So this is for C. Now, for D, they asked you to solve 2x squared minus 3x minus 27 is equal to 0 by first factorizing it, the factorization method, and the second one is using the quadratic formula. So let's use the factorization method. So I have 2x squared minus 3x minus 27 is equal to 0. Now I need to think about two brackets, right? The first bracket, it will be a number times x. Second bracket, it will be a number times x. And then I have two numbers here that their product is equal to negative 27. Well, from the negative 27, I understand that the two numbers here got different signs, right? For example, I can think about negative 9 and 3, negative 9 and 3, or 3 and negative 9. And here it comes, it's for you to try which one is better for you, right? So for example here, for the first coefficient here, I will choose to put 2 and 1. Well, I'm not obliged to put not 1 here, but I can write like that, 2x times x, like that. And I will put, for example, the negative 9 here, plus 3. And let's see if I will get a good factorization or not by expanding this to see if I will have the same solution here. So 2x times x is equal to 2x squared. Well, I got the first term, which is normal. 2x times 3 is equal to 6x. After that, negative 9 times x is minus 9x. After that, negative 9 times 3, so minus 27. is equal to 0. If I would collect these two together, I will have negative 3x. Right, imagine I got plus here and minus here. I'm trying to show you that it's okay to get it first wrong, but you need to know how to correct that. Imagine I got plus here and negative 3 here. So the first two terms, it will be the same thing. This one, 2x squared, because 2x times x is 2x squared. 2x times negative 3, it will be minus 6x here. And after that, 9 times x is plus 9x. And 9 times negative 3 is negative 27. So if I'm looking at these two, negative 6x plus 3x, it will be 3x. It's not the number that I have in the equation. So this is why this factorization is not good. So this is why I need to return the signs as I got them, right? And you don't need to write anything of this in your paper, right? So this is exactly what you need to show in your work, because we really don't care about how you got this, right? If you got the idea, if you show it directly, the most important thing, you are not cheating, for sure. But this is the most important thing. And don't worry, if you are cheating, they will know in your other exercises. Right, so I have 2x minus 9 times x plus 3 is equal to 0. So it means that I have 2x minus 9 is equal to 0, or x plus 3 is equal to 0. Then 2x is equal to 9, or x is equal to negative 3. I just need to move the second term to the other side. It will go with the opposite sign. And then if 2x is equal to 9, then x is equal to 9 over 2, or x is equal to negative 3. Then x is equal to 4.5, or x is equal to negative 3. Right, here, since, well, don't forget x is the price of a large sack. So is it possible for it to be a negative number? For sure not. So the only solution I need to keep is x is equal to $4.5, right? This negative 3 is not a good solution, right? So the only solution for this problem is $4.5. Right, after that, they ask you to use the quadratic formula for this one. So I have 2x squared minus a 3x minus 27 is equal to 0. It's in the form ax squared plus bx plus c is equal to 0. So a is equal to 2, b is equal to negative 3, and c is equal to negative 27. Right? Now, the solution, so the first solution is equal to the solution. Well, it's up to you if you want to calculate b squared minus 4ac first. So I have 9 minus 4 times 2, well, times negative 27. So I can write like that. Minus 4 times 2 times negative 27, which is equal to 9 plus 8 times 27. It's up to you if you want to calculate this one or not. So let me calculate this rapidly. Yeah, so I have 9 plus 8 times 27. So it's 225. 225. If you take the square of that, it's 15. So it's 15 squared, this one. So if I would like to calculate x1 and x2, x1, the first solution is negative b plus square root of b squared minus 4ac divided by 2a. And the second solution is negative b minus square root of b squared minus 4ac divided by 2a. So negative b is 3 plus square root of 15 squared is equal to 15 divided by 2 times 2, which is 4, right? So 17 divided, 18 divided by 4 is equal to 9 divided by 2, which is 4.5. And this is reassuring because we got the same solution as the first method. After that, I have 3 minus 15 divided by 4, which is equal to negative 12 divided by 4, which is equal to negative 3. And I got the same solution as the first method. So this is really reassuring for me. Now, after that, calculate the number of sacks which Paul buys. So I know from the start, we got an expression for that from the start. So the number of the sacks that Paul bought is, in terms of x, is 27 divided by x, right? So the number of sacks that Paul bought is equal to 27 divided by x. We know the value of x. X is equal to 4.5 here. We already know. So the price of one sack, large sack, is equal to 4.5. So you just need to do 27 divided by 4.5, which is equal to 6 sacks. All right, well, I hope that was helpful for you. Let me know if you need more explanation about that. And thank you for watching. Bye-bye.